As far as the standards that we use for wireless networking, there's several different standards bodies that create the wireless definitions that we use to deploy our wireless networks. So first we'll start with the Wi-Fi Alliance. Now the Wi-Fi Alliance is a non-profit industry trade association that promotes wireless interconnectivity between vendors. It also ratified a couple of the encryption technologies that we use. We have WPA, which is Wi-Fi Protected Access, version 1 and version 2 of that technology, which we'll talk more about how WPA is going to help you in keeping your data from prying eyes. Then there's the IEEE, the same group that ratified the standards that we use for Ethernet. We just spent a bunch of time talking about. So in particular, the 802 committee, 802.11 committee, that has all the documents in conjunction with wireless technical standards. And then lastly, of course, would be the ITU, which is the International Telecommunication Union radio communication sector. These guys are in charge of helping different entities within government regulate the use of radio frequency within their scope of control. As far as the ITU is concerned within the United States governing body that controls frequency of transmission would be the FCC. So the Federal Communications Commission controls what frequencies are registered within the United States. Various frequencies are set aside and licensed to radio stations, television stations, and so on. But there are set-aside bands that are considered free use bands. We have the ISM band, the Industry, Scientific, and Medical Frequency band. We also have the higher level bands, which include the 5 gigahertz band and a lower band for usually used for phones, the 900 megahertz band as well. So of these three, we have as you can see here, the 26 megahertz space of the 900 series band, 83 megahertz of space in the 2.4 gigahertz range, and then 5 gigahertz, which may vary depending on the country you're dealing with. Some countries have certain parts of that 5 gigahertz band open, others don't. Here in the United States, there was, part of our missile defense system was occurring on the 5 gigahertz range, as well as some tower frequencies for communication between airplanes. So we didn't want to step over that, so there's some rules on how you have to use the 5 gigahertz band with respect to wireless Ethernet. Now, as far as the technologies we use for wireless LANs within these spaces, 802.11b, G, and now N occur inside the 2.4 gigahertz range, where the 5 gigahertz range is specifically the space of 802.11a. Now, 802.11a runs at 53 megabits per second, whereas the 2.4 gigahertz, the G range, runs roughly the same speed. N runs twice as fast, say 53, 54 megabits per second. But in either case here, G didn't get as much deployment as B and G did, simply from the fact that the G range, because it's a lower frequency, got a farther distance with the same antenna power. You'll find that inside a corporate environment, though, it's generally preferred that you deploy 5 gigahertz because you have a lot more non-overlapping channels that you can deploy for the drawback of having smaller cells in which you have to deploy. So you have to deploy more access points, but that may not necessarily be a bad thing in a corporate environment, because for each access point, the number of users using it in a shared environment is going to be increased, and therefore their bandwidth is going to be shared and divided amongst all those users. So as far as my general recommendation for a large environment, 5 gigahertz is usually where I push people.